2.8 is solving we talked about solving equations, and now we're looking at solving inequalities. When we talk about solving inequalities, we're not talking about just the linear inequality type where you can solve x, get x by itself, and it's x less than or greater than some number. Okay, we're talking about when we are higher degrees here. Okay, so x to the second, x to the third, x to the fourth. How do we solve and deal with those? Okay, so we're going to start by looking at this polynomial here and talking about how to know when it equals 0, when it's positive, and when it's negative. Because if we know when it's positive and when it's negative, that will help us with inequalities when it's less than or greater than 0. So, in example 1, we are given f of x, and we're asked to use a number line to determine the real number values of x that cause f of x to be each of the following. So, we're doing that all at once in a way here, but we're going to want to know, okay, when is this function equal to 0, when is it positive, and when is it negative? And we'll use interval notation to express our answers, as you should be doing throughout homework, if I recall correctly. Okay, it's interval notation. I don't remember what form the answer or the book will have it in, but I'll be looking for interval notation. So as we look at A, thoughts on how to know when this equation is going to be 0. Because why? Okay. So the advantage here on A, or on example 1, is this is already in factored form, yes? If it's already in factored form, then it's setting each factor equal to 0, correct? So, thus, when Autumn's talking about -3, it's because she's taking x plus 3, setting it equal to 0. So, we know one place that this function will equal 0 is at -3. Because if I plug -3 in for x, I'm going to get 0. What else do I need to do then? Okay. Set each factor equal to 0. X squared plus 1 equals 0, and x minus 4 equals 0. What about that x squared plus 1? Yeah, we're getting x squared equals -1, and then you take the square root there, and we're going to get the square root of -1, which is I. Are we talking about I if we're looking at graphs? No. So in this case, that one's just not going to matter. Okay? X squared plus 1. You put a number in for x, you square it, and you add 1. You're never getting 0. You're always going to be getting something positive because you're always taking some positive number or 0 and adding 1 to it. Okay, and then our other one, of course, is x equals 4. So those are each of the places that this polynomial can equal 0, at -3 and at 4. Now, in terms to talk about B and C, where it talks about positive and negative, we're going to use a number line. Okay, and this is one of the techniques I'm going to teach today, where I'm going to teach a couple different techniques throughout the lesson. But we're going to talk about a number line. So as we talk about number line, set up a number line over here. I need my zeros on the number line. So the two values I came up with, which were -3 and +4. I don't need all the other numbers in there. Okay, and I just kind of evenly space those because what I want to know is what's happening in each section. In each section, is my graph going to be positive or negative? Positive or negative? Positive or negative? How can we figure that out?
Anything the left of -3 because it just keeps increasing. Right?
Are you talking about the x values? Huh?
Is that a valid explanation?
Well, my x values will be negative, but I'm not talking about x values. I'm talking about y values. I'm talking about this function here. When I plug in any value over here, what's it going to make the function do? Pick a value and test it. Okay, and we've done this a little bit before, but pick a value and test it. So pick a value left of -3. Don't pick -3, because if I put -3 in, I'm getting 0. But pick a value. So for instance, I'm going to pick x equals -4. Pick -5, -6, -10. It doesn't matter, okay? And what we're going to do is we're going to plug it into this form here. Okay, so I'm not going to get number values. I'll bring this over here. I just care about signs. So for instance, I plug -4 into here. What do you know about -4 plus 3? -4 plus 3 is a negative, yes? What do you know about -4 squared plus 1? Well, anytime you square something, it's going to become a positive. You add 1, it's going to be a positive. Now, this one over here, -4 minus 4 is a negative, but then what do we still have to do with it? Square it. So when you square it, what's that going to become? That's going to become a positive. If you multiply a negative times a positive, what do you get for that interval? A negative. So I know no matter what value I put in here over to the left of -3, I know my graph's going to be negative here. Okay. Repeat the process. Pick a value between -3 and 4. What's a value between -3 and 4 I can use? I'm always going to use 0 where I can. So we're testing x equals 0. What do I know about 0 plus 3? It's a positive. 0 squared plus 1? Positive. 0 minus 4, quantity squared. Well, 0 minus 4 is a negative, but then when we square it, it's going to be a positive. What happens when you multiply all positives together? You get a positive, yes? And test one more section. Now I need to use something bigger than 4. So 5 or bigger pretty much. Or throw a decimal in there, whatever. What do you know about 5 plus 3? It's a positive. 5 squared plus 1, well, that factor is always going to be positive. And if you figured this one out, 5 minus 4, quantity squared, is also always going to be positive. When you multiply all positives, you get a positive. Okay, so, and keep in mind that at -3, this was a 0, right? And at 4, this was a 0. Okay, so we already answered part A, in that when is this polynomial 0? And that was at -3 and at 4. When is this polynomial positive?
-3 to infinity.
Almost. I have to be nitpicky here. No.
From -3 to 4.
So these are both positive sections, yes? And so we are going to start at -3. We'll talk about parentheses versus bracket here in a moment. But what do we know about 4? Is it the graph positive at 4?
It's a 0.
It's a 0. So we can't include 4, which means we have to talk about 2 separate intervals. So we're going to talk about the interval from -3 to 4, and then the interval from 4 to infinity. Now, I didn't put any marks in there because I'm going to make you guys think about that. -3, parenthesis or bracket? Parenthesis. Does it include -3? No, because -3 is a 0. We are only talking about when it's positive, so it's a parenthesis. What about 4? Do we include 4? No. 4 is also a 0, so it's not positive there. So -3 to 4. Do I have a U for union in my notes? Probably. I do. U for union. What's this 4 going to have? Parenthesis. And what's infinity always use? Parenthesis. And then, where's my graph negative?
Negative infinity to -3.
Okay, so everything to the left of -3. When we start over there, when we start over in Mr. Stanley's room, we use negative infinity. So negative infinity to -3. Negative infinity is parenthesis, -3, parenthesis. Okay. As you work through homework and whatnot, you're going to have interval notation. So that's a little bit of a review of interval notation there. Now, one little side note, and I don't know, when we worked through this, where you kind of jumping ahead and saying, oh, it's negative, it's positive, I'm guessing it's going to be negative here on the other end. I don't know if that was happening or not out there. But did we just talked about multiplicity and crossing and touching recently, didn't we? That was even this unit, if I'm not mistaken. But with that in mind, okay, this x plus 3 had a factor or an exponent of 1. 1 is an exponent or a multiplicity that is odd. What do we talk about at odd multiplicities? It's going to cross. So that would explain that my graph is going to cross at -3. So does it make sense that if it's negative on one side, it's positive on the other side? Okay. What about 4? X equals 4 came from this right here, which had a multiplicity of 2. A multiplicity of 2, well, what do you know about 2? 2 is even, and what's an even multiplicity say going to do? It says we're going to touch. So what happened here? This graph was positive. It came down, it touched 4, and then it went back up. Just trying to show you it all goes together. Okay? As you're working to see all of this, I promise, it all goes together. So, okay. This is kind of your intro. Okay? I think you have a little bit of this at the beginning of homework, if I recall, where they're asking about 0, positive, and negative. But for the most part, we're going to take one big problem and just ask, okay, where is it greater than 0, less than 0, whatever the case is. So, ready for example 2? Okay. In this particular one, we're going to talk about solving more analytically. So this is more of using algebra and a sign chart. This is not so much looking at the graph. Okay? When we talk about example 3, we will totally rely on the graph in our calculator. This one is, we're going to pop in and look at the graph a little bit, but not so much here. Okay? So, now, the question here is to solve 2x cubed minus 7x squared minus 10x plus 24 greater than 0. So, as I said, analytically, so we're talking algebra and a sign chart. I didn't put the numbers up there. I'll have to get the numbers. There's certain numbers in homework. Did I write it in my plan book and just not? Okay, I have it at the end of the homework. 2 through 12, use the sign chart. You'll graph the others. That's what it is. Okay, now, remember, if your equation is greater than 0. Okay, so f of x greater than 0. Greater than 0 means we're going to look for where the graph is positive. Okay. If you have a function that is less than 0, then we're going to be looking for where the graph is negative. Okay, we've talked about that before. In this case, the problem with this problem from the original problem was factored, wasn't it? I knew where it crossed the x-axis. This one is not factored. Is it something that I can easily factor just by looking at it? No. It's not a product in sum factoring. I will say when I see 4 terms, I would tend to ask myself, okay, can I factor by grouping? As in, can I divide it in half? And I could pull some GCFs out, but I'm not going to be able to get matching parentheses. So that whole factoring by grouping thing isn't going to work either. So we need to go back and talk about PRRs. Okay, so this is, on 2 through 12 when we're trying to talk about analytically, algebraically, we want to talk about PRRs. So, remember anything about PRRs? Okay, the n number that doesn't have an x, aka the constant is what I'll call it. Okay, so factors of the constant over factors of the lead coefficient. So that means in this case we're going to do factors of 24 over factors of 2. Oh, what you got for factors of 24? I'm thinking in pairs in my head. Are you thinking in pairs of your head? So I know 1 has a pair, 2 has a pair, 3 has a pair, 4 has a pair, 5 does not, and now we're doing the other set of pairs, aren't we? 4 and 6, 3 and 8, 2 and 12, 1 and 24. All over factors of 2. One and 2. Okay. Now, and here's what I'm going to suggest for PRRs here, guys. You've got a list looking here, yes? You can go another step and write them out to see what all the options are. Basically, we have all the numbers on top as options, yes? Plus all of those numbers divided by 2 as options, right? PRRs give us a list of places to start. We can start just guessing and trying and finding out which ones work. Or take a peek at the graph. And that's going to be my suggestion, is that we take a peek at the graph to get an idea of what might work. Okay, so throw this in the graph. And we're going to look and see, what does the graph suggest? Do I even need to graph this? By the time I get this graphed, you guys should hopefully be there, have some answers for me. And remember, I'm not looking for you guys to get all fancy with your calculator or anything. Just, I graphed it. Can I take a peek and take some guesses? Okay. Not trying to find zeros or anything like that, but based on what's in my list over here and what this graph looks like. What are your guesses?
2.
So, -2, +4, +3/2. Would that make sense?
Yep.
Okay, and this is where if you start looking, okay, it has to be something, my options are whole numbers or things divided by 2, right? So I do have a 3/2 here as an option, don't I? So 3/2. And here's the deal. I'm going to say that one that looks like 1.5 is probably 1.5. It's not going to be some big long messy decimal, and I know that because the big long messy decimals happen in pairs. Our imaginary roots and our irrational roots occur in pairs. Is there another one that it matches up with on the other side? No. Okay. So based on the graph, these are the values that we're guessing we need to do. Okay. So how do we figure out what works here? What do we do with them now that we think they're going to work? Synthetic division. Okay, synthetic division is what allows us to factor this down. Since this isn't factorable by our normal, easier methods, synthetic division is going to factor. So let's take the first suggestion. The first suggestion was -2. Put -2 in your box for synthetic division. Numbers next to it are going to include 2, -7, -10, and 24. Any placeholder zeros? No? Okay, so let's confirm that -2 works. You guys remember your synthetic division?
Yeah.
Drop the 2, multiply. -2 times 2 is -4. Then we're going to add. -7 plus -4 is -11. Then I'm going to multiply. -2 times -11 is 22. Add. -10 plus 22 is 12. Multiply. -2 times 12 is -24. 24 plus -24 is 0. Did it work? Of course it did. Not surprising, but we need to know that it works. So now, what I know at this exact moment in time, -2 worked. What does that represent as a factor?
2x squared minus 11x plus 12. X
Oh.
plus 2.
Okay. I'm looking for x plus 2 right now. I understand where you're at. I was really confused for a moment. I was like, what is she talking about? But I'm there. So -2, that's x minus -2, right? X minus -2 is x plus 2. Now, we have this piece here, yes? The 2, -11, and 12. We're going to use that now to do what?
Factoring.
Yeah. We're going to continue factoring, which is why we need to use this new one with our next synthetic division piece, which now we're going to try 4. So 4 in the box. And now instead of going back to our original list of numbers, 2, -11, and 12. Because we're doing synthetic division, but we're factoring. That's what we're really doing, is we're factoring. Okay? Drop the 2. 4 times 2 is 8. -11 plus 8 is -3. 4 times -3 is -12. 12 plus -12 is 0. Okay, so 4 works. What is 4 as a factor? X minus 4. Now, you can go ahead and do the next one. However, what factor do I have right here? That is 2x minus 3, yes? Does 2x minus 3 match up with our other piece that we thought we were going to have to use? Yeah, if you take 2x minus 3 and you solve it, that is 3/2. So you don't have to do that last round of synthetic division. You can. You get a 0. There's very minimal stuff there. But once you get to that piece, we can stop there. In all honesty, if we wanted to stop here at 2x squared minus 11x plus 12 and do a slip and slide or product of AC, we could have factored that right there. But I think synthetic division is just as easy at that point. Okay, so what we've done is we took that 2x cubed minus 7x squared minus 10x plus 4, and we have factored it. We can use that factored form with our number line. Okay, we're going to do like what we did back on part 1. So, let's see. Our original function, I'm just going to write it out, was, 2x cubed minus 7x squared minus 10x plus 24. But now, guess what that is? That now in factored form is x plus 2, x minus 4, and 2x minus 3. We can use that to do our testing. Okay? And again, this one specifically, I'm asking you to use algebra and sign charts. We won't always use a sign chart, but I need you to know how to do the basics here. So, what numbers need to go on my number line? And the 3 halves. Okay? Any place my graph was 0, it's going to go. Okay? So put them in numerical order. So -2, 3 halves, and 4. Okay? So when you're asked to do a sign chart, this is what I'm talking about with a sign chart, when you're asked to do a sign chart. So pick a value and test. What do you want to test? Left of -2. I would probably test -3. Do I need to write that out or not? I don't know. If I test -3, so what do you know about -3 plus 2? It's negative. What do you know about -3 minus 4? It's negative. 2 times -3 minus 3. It's a negative, yes? What is a negative times a negative times a negative? It is a negative. So I know this whole section here is a negative. Something between -2 and 3 halves. I say, I'm personally going to use 0, definitely. What do you know about 0 plus 2? It's positive. 0 minus 4? It's negative. 2 times 0 minus 3 is negative. What do you know about positive times a negative times a negative? It's a positive. Okay, keep going. Pick a value between 3 halves and 4. Yeah, pretty much 2 or 3 if you want to use a whole number. So, let's see. I know 2 plus 2 is positive. 2 minus 4 is negative. 2 times 2 minus 3 is positive. Positive times positive is a negative. Okay, and I need a value bigger than 4. 5, 6, 7, you pick. Okay, so 5 plus 2, 5 minus 4, 2 times 5 minus 3, all positives. All positives multiplied together results in a positive. Okay, now, here's the question. What is our question? We've got this sign chart. What are we trying to ask? What was the original plan here? I don't know that I ever really talked about what the original plan is. I just jumped in.
Where the graph is positive.
Okay. This question was greater than 0, yes? Whoops. If we want to talk greater than 0, which is what we're doing here, we want to know where the graph is positive. Okay, so since my problem was greater than 0, where's my graph positive? On what intervals? Between -2 and 3/2, and what was the other one? And 4 to infinity. Okay, well, infinities always use parentheses. The others. The question was greater than 0. Do we care that it equals 0? No. So, do we use parentheses or brackets on these others? At these points, these are zeros, aren't they?
Yeah.
We're only being asked about positive, so all of our pieces are going to include parentheses. So -2 to 3/2 and 4 to infinity. Now, when would we change that up? If this problem instead said greater than or equal to 0, then we could talk brackets, because then if it says greater than or equal to 0, we would want to include those pieces. So we would use brackets then. If it does not say equal to, you're going to stick with parentheses. Okay? I'll be honest, this is the long way to do it, okay? But we have to know kind of the basics, how this works. So on, I believe what I said is that 2 through 12, which is evens, right? But 2 through 12, I'm going to ask you to use the sign chart. Past 12, I'm going to ask you to look at the graphs. And we're going to talk in example 3 about how we can look at the graph. Okay? Let's go ahead and look at this a little bit. I don't know if I get this done in 5 minutes or not. We'll see. You guys are like, no way. But as you look at example 3, solve x cubed minus 6x squared less than or equal to 2 minus 8x. Notice it says graphically. Okay? Graphically, and there's a reason for that graphically, and I'll explain once we look at, well, I say basically it comes down to it's not going to factor out. It's not going to have nice neat factors. It's not going to have nice neat zeros. We're going to be working with decimals here. And so that's why we're going to use the calculator. Now, what has to happen here before I can use the calculator? Yeah, you need this to be equal or less than or equal to or greater than or, you need everything on one side. So let's start by getting that, which that means in this case, what are we going to have? X cubed is going to stay on the left. Minus 6x squared is going to stay on the left. What else has to happen? We're going to add the 8x over, and we're going to subtract the 2 over. And so now I have x cubed minus 6x squared plus 8x minus 2 less than or equal to 0. So, what is it that we're going to graph now? We're going to graph y equals x cubed minus 6x squared plus 8x minus 2. What are we going to be looking for on the graph? Okay, we're going to have to look for our zeros. And as I said, they're not nice neat whole numbers, which means it doesn't factor nicely. And then less than or equal to 0. What's that tell me?
Where is the negative?
Yeah, we're going to be looking for where the graph is negative. Okay, now, what's that look like on the graph? If we're looking for where the graph is negative, we're looking for what location? Where the graph is below the x-axis. Do we care where it touches the x-axis? It does say equal to, so we're going to be looking for on or below the x-axis. Okay? We're going to be looking for on or below the x-axis. Okay. So we're going to graph this. Once you graph it, you are going to need to figure out what are your zeros. And then in all honesty, you'll be able to do the problem. Okay? So, have some of you already thrown it in the graph? X to the third, 6x squared, plus 8x minus 2. Okay. Do those cross at nice, neat, whole number zeros? They don't, do they? Okay. So, I'll have to pick up here tomorrow. Awkward place to stop, I know, but we'll pick up and look at this tomorrow. Start tomorrow by finding your zeros. And honestly, once you know your zeros, you can see where the graph is. You'll have your answers. Okay? On the back side tomorrow, we will look at a few more graphing examples, really just some unique answers and when there's some asymptotes and things like that.
That church so fast. Up until I knew it was gonna die, that was like